Okay, good morning, good afternoon, and good evening to everyone. In this video, I just want us to look at some of the revisions so far with some of the revision questions where we can basically be able to practice one or two with regards to the upcoming tests on Thursday. So, my revision is coming from worksheet 3. I'm going to start with the first question, which is talking about sketching by transformations. Yeah, that's the one I'm going to start with. Then from there, we'll be able to pick it up with other revisions questions. So, you can look at your worksheet 3, question 8. Which is giving us a number of instructions there to be able to look at. So question 8 says that a function f is given and the indicated transformations are applied. A function f is given and the indicated transformations are applied to its graph, and it's given in that order. So we're being taught to say write the equation of the final transformed graph. So the first thing when you look at question 8 is that you cannot transform or write the final equation if you do not know the transformational rules. So what are you expected to do? Know the transformational rules first. So what are the transformational rules you're supposed to know? So there are just basically 8 of them. So in the transformational rules, we are simply saying that we are going to have a situation where you can have h of x to be equals to f of x plus k. This is a certain transformation where f of x has transformed using the vertical translation of k. So this is a new function h of x transforming f of x. So what is happening here? To f of x, we have added a constant k. So it means that the graph for f of x will move upwards k units or move downwards k units depending on the nature of this k. So if it is plus k, therefore we are expecting that f of x is going to shift k units upwards. If it is in a situation whereby we have h of x to be equals to f of x minus k, expect that we are going to have f of x shifting k units downwards. So this is what I always focus on. If the transformation is happening outside that given function, then just know that that kind of transformation is happening as a vertical transformation. If the function, or maybe the transformation is happening inside the function, so you can have h of x to be equals to f x plus h. So this one, it is h being what is added inside the function and not outside the function. So the inside the function, this one is talking about a left and right shift. So if it is plus, f of x is being shifted to the left. And if it is a situation whereby it is h of x to be equals to fx minus h, this is an indication that f of x is shifted to the right. How many units? H units. Shifted to the left, h units. And shifted to the right using h units. So this h is just representing any constant value which can be added inside the function. So now These are the first four main ones. So these first four only talks about the up and down, as well as the left and the right. If the transformation is happening inside, it is the left or right. If the transformation is happening outside, it is the up or down shift. So these four transformations are basically called the translations transformation. So the first two are basically the vertical translations, and these other two are called the horizontal translations. So vertical outside the function, horizontal inside the function. So we are going to look at the first letter A, where we're being told to say what is the final graph if f of x equals to x squared. So this is the original graph which has been given. Now what would be the final equation if this, we are basically being told that it shifts upwards. It shifts upwards by 3 units. So there's a concept of 3 units here. It shifts upwards by 3 units. And it shifts 2 units to the left, to the right. So upwards it is plus k outside the function. Right or left, if it is right, it is minus h inside the function. So you look at the function. What kind of function is this one? This is a square function. Inside the square will represent a horizontal translation. Outside the square, there will be representation of the what? Of the vertical translation. So what will be the solution for this one? We can represent h of x to be our final equation where, because of this right, it means I'm experiencing a horizontal shift inside the square. So it is x squared, and then upwards it means that upwards it means plus k, so it is plus 3 units. Inside here to the right means minus h, so it means how many units in this case? Minus 2. So this will be our final equation for this function, where we're simply saying that inside the given function represent horizontal translations, outside the function represent the vertical translations. So shift upwards by 3 units. This is a 3 which will be outside the square function, but the shift 2 units to the right, it is the transformation of 2 inside the function. So the left and right happens inside, the vertical, the up and down happens outside. So take note of the given function. This is a square function. So inside it happens the square. If it was an absolute value, the inside, the horizontal translation would have happened in the absolute value. If it was a root, the horizontal translation would have happened in the root function. So that is the first one. Let's look at the second one, B. So we have the second one. What is the final equation for this transformed function? F of x is the absolute value of x. What are we being told? It shifts to the left by 1 unit, stretch vertically by a factor of 3, and shift upwards by 10 units. So we know the left and the right shift, that it is in the horizontal. We know the upwards and the down shift, that it is the vertical shifts. But what do we mean by the stretches? So basically what is happening here is that we know that we can have a situation whereby this h of x can be equals to a. This a is multiplying the function f, and inside the function x there can be a plus h, and outside the function there can be a plus k. So what does this indicate? The outside, the addition of the outside here, this means it is the up or down shift, the plus k. So if it is plus k, k units upwards, the f of x function is going to shift k units upwards. The h inside here indicates that it is going to either move to the left or to the right. So the plus h, it is an indication it's going to move to the left. So now what about this a here? This a symbolizes that this can be a vertical stretch. So it means that f of x stretch vertically if a is greater than 1. So the function will stretch vertically if this a is a whole number which is greater than 1. And then we are simply saying that this function f of x can shrink vertically if this a here is in between 0 and 1. So in between 0 and 1 symbolizes that this a which I'm looking for should be a fraction. Obviously it can be 0.1, 0.2, 0.3 up to 0.9 something, as long as that a is in between 0 and 1. So if we have a fraction, the fraction multiplying the given function, the original function, then we can experience a stretch vertically or a shrink vertically. So this is what this is talking about, the stretch vertically. Sometimes we can experience a stretch horizontally or a shrink horizontally. This is a situation where we have h of x equals to, let's say f, the constant is multiplying inside the function a of x. So if the constant is multiplying inside the function, this a will no longer be a vertical stretch or horizontal shrink or a vertical shrink, but this time around this a can be making the function f of x to stretch horizontally or to shrink horizontally. So if the a is multiplying outside the function, I'm going to experience a stretch vertically or a shrink vertically depending with the condition of that a. But if the a is inside in here, so if the a is inside multiplying in here, then I'm going to experience a horizontal shrink or horizontal stretch. So we have a horizontal shrink if this a is greater than 1. So now take note of what is happening here. If this a is greater than 1, which is multiplying outside, there is a vertical stretch. But a multiplied by x in the function a multiplied by the hand, it is a horizontal shrink if a is greater than 1. So in the horizontal, things behave oppositely. Whole number causes a horizontal shrink, but once it's a fraction, causes a horizontal stretch. So that's what usually happens. So now what is this b saying? It means that this absolute value here undergoes shift to the left. It means the left shift is inside the absolute value. So the final function will be h of x to be equal to the absolute value of x. The left means I'm adding 1. Upwards means we are adding the 10. But keep in mind there is a stretch vertical by a factor of 3. So the 3 is multiplied outside the given function. So this becomes my equation of the final graph. Let's look at the third one. So we have C there. Now this time around C is a root function. Given that f of x is equals to the root of x, and this root of x, are being told that it reflects in the y-axis, and then we're being told that it also shrink vertically by a factor of 0.5 and shift pi units to the left. So automatically at this stage, I know if anything to do with the left or right, we know what is happening. If anything to do with the shrink vertically or stretch vertically, we know what is happening. Maybe the only new thing here is a reflection. So what is happening here? we are simply saying that if we have h of x to be equals to the negative of f of x, a negative in front means this is a reflection in the y axis. But if we have h of x equals to f of negative x, if the negative inside the function, this is a reflection. So this is the first one is a reflection in the x-axis, and then this one is a reflection in the y-axis. So if we want to have a reflection in the y-axis, the negative should come inside the function. If there must be a reflection in the x-axis, the negative should be outside the given function. So what is happening here? We have our final graph h of x to be equals to the original graph is the root of x. So in the root of x, what are we being taught? There is a pi units to the left. To the left means it is plus pi. And then there is a shrink vertically by 0.5. So 0.5 is multiplying the function outside. So what am I going to have? I'm going to have 0.5 multiplied by the root of x plus pi. But there is another concept where simply the reflection in the y-axis. In the y-axis means the negative should come inside the function. It won't be outside. If it is outside here, it is in the x-axis. But if I take it inside, then it becomes in the y-axis. So there must be a negative here. Keep in mind to put your brackets like that. So there's a negative in front of this bracket. So this is my final graph for this function. Okay. So we have the other one, last one on question 8. So this one says that if we have f of x to be equals to the x power 3, which is a cubic function, and then this f of x equals to x power 3 shrink horizontally by a factor of 0.1, and then we're being told that it shifts 6 units to the right and 3 units downwards. What would be the final equation for the transformed graph? So now, with this one, I'm emphasizing on the stretches and the shrink. So let me give an example. If I have f of x, let's say if I have h of x to be equal to 2 f of x. So 2 is multiplying the original function f of x. What does this indicate? This is a vertical stretch, isn't it? This is a vertical stretch because the value of 2 is greater than 1. But if I have h of x equals to 1 over 2 f of x, this is less than 1. So it means this guy is making the function to what? Shrink vertically. So I'm going to have what is being caused here, it is a vertical shrink. That is what is happening there. So if this is the case, now when I want to explain something to say, okay, this function is undergoing a vertical stretch. The question is, the vertical stretch is happening by what factor? So the vertical stretch here is happening by a factor of 2. So it means that all the y coordinates are being multiplied by this factor 2. So the vertical stretch here is by a factor of 2. But if you look at what is happening within the shrink, we are simply saying the vertical shrink is happening by a factor of 1 over 2. It means all the y coordinates will be multiplied by what? will be multiplied by 1 over 2. We're getting it? So what about if it is a situation whereby I'm talking about the horizontal stretches and shrinks? I'm going to have in a situation whereby I have h of x is equals to f of 2x. So I'm going to have these two. When it comes to the horizontal stretches and shrink, if this value is greater than 1, it is not a stretch horizontally, but it is a shrink horizontally. So this 2 is causing the function to what? Shrink horizontally. But if I have h of x equals to f of 1 over 2x inside there, this is less than 1. It's causing the function to what? Stretch horizontally. Now the question is, if it is shrinking horizontally, what is the factor? What is the horizontal shrink factor? It is shrinking horizontally by a factor of 1 over 2 for this one. So if it is a 2 here, it means that the function is shrinking horizontally by the reciprocal of 2, which is basically 1 over 2. If it is 1 over 2 here, it is causing the function to stretch horizontally. But in the stretching of the horizontally, it is stretching horizontally by a factor of 2. So now I was simply saying in the horizontal, things are a little bit of opposite. If it is a whole number, it is a shrink. If it is a fraction, it is a stretch. But the factor of that shrinking is the reciprocal of that constant. But in the vertical, it follows whatsoever you have. Whole number is stretch and the same factor. Fraction is shrink and that same factor. But in the horizontal, the whole number, it is a shrink, but the factor of 1 over 2. In the fraction, it's a stretch by a factor of 2. So this is what is also happening here. So if f of x is x power 3, it means that it is shrinking horizontally by a factor of 0.1. So there's a horizontal shrink here. There's a horizontal shrink here. So for them to say it is shrinking by 0.1, it means that there's a constant who is a whole number multiplying this function inside. So I'm going to have a new function h of x to be equals to, in the function x here, there's a certain value multiplying this x right to the power 3. So for it to shrink 0.1, 0.1, remember this 0.1 is the same as 0.1 is the same as 1 over 10. So we're simply saying that 0.1 given there is basically the same as 1 over 10. So if we're simply saying that this function shrink horizontally by 0.1, it means that in the equation it is a reciprocal of this. So what is going to happen? I'm going to have h of x to be equal to, I'm going to have h of x to be equal to 10 multiplying by x power 3. So now, what are we simply saying? If it is a whole number here inside, there must be a shrink horizontal. But by what factor? The reciprocal. So the factor which is making this function shrink horizontally, it is the reciprocal, which is 1 over 10. And 1 over 10 is the same as 0.1. So h of x will be equals to 10 inside x, which is causing it to shrink horizontally. It can only shrink if this value it is greater than 1. So it makes sense. 10 is greater than 1, it is shrinking. But by what factor? The reciprocal, which is 0.1. So, and then what else are we being told here? We are simply saying that it shifts 6 units to the right. So it means that before I apply this 10, it means that my function should be h of x to be equal to, open bracket, 10, open another, x to the right means minus 6, you close, and this is power 3. So what am I going to experience now? So the inside here represent horizontal transformations. The minus 6, it is moving to the right. The 10, it is multiplying the function here by 10, causing a horizontal shrink by a factor of 0.1. And then 3 units downwards. The downwards means I'm subtracting this function minus 3. So the final function will be this one. H of x is equals to x minus 3 power 3 minus a 3. That will be the final equation for our function. So we have shifted to go look at question 4 of the same worksheet 3, where the question says that consider the graph of f. Then we're being told to say write down the transformation that should be applied to the graph f in order to get these final graphs. So what transformation was applied to f so that we can be able to get this? Use the same rules. So you look at this. What was happening to f so that we can get h of x? So what do you notice? You have a plus 5 outside the function and you have a 2 inside the function multiplying. So the 2 inside, this one represents a what? Horizontal shrink. This one represents a what? Upward by 5 units. Isn't it? So we want to write those in statements to say what is happening. So now, for this to be horizontal shrink, it means it's greater than 1. But when writing, it's by what factor? By a factor of the reciprocal. So if it is 2 here, by a factor of 1 over 2. That's what happens in the horizontal. But if it was a vertical stretch or shrink, we would have just gotten the same factor. So what are the transformations? So the transformations are that f of x shrink horizontally by a factor of 1 over 2 and shift 5 units upwards. Okay? And then next we look at g of x. G of x, before you do anything, you have to take care of the inside here. Write the inside. So this g of x is the same as the negative of f, open, there is a 1 over 2 which has been factored out, so that you can just remain with x minus 2. Once it is written like this, at least you'll be able to write the correct transformations. So you factor 1 over 2, but still in the brackets. You factor 1 over 2, then there's a plus 3. So now the 1 over 2, it's still inside the function. 2 talks about the what? Since it's a fraction, it is a horizontal stretch. By what factor? A factor of what? The reciprocal. Factor of 2. This minus 2 shifts to the right. 2 units. This plus 3, upward shift 3 units. This negative, what does the negative here? A reflection in the what? Reflection in the x-axis. So this is the information I'm going to just write. So what am I going to say? H of x stretch horizontally by a factor of 2, and so stretch horizontally by a factor of 2 shifts 2 units to the right. After that, we're talking about reflection in the x-axis and shift 3 units upwards. Let's hope these handwritings are visible. My board is very small. 3 units upwards. That will be the transformation. So just look at what is happening. 1/2 horizontal shrink, because it's a fraction. Here it was a 2. It becomes a horizontal shrink. What factor? The reciprocal. What factor? The reciprocal. So the factor of 2, but here it was a factor of 1/2. That's how we explain this. The negative reflection in the x-axis, plus 3 upwards, 3 minus 2 to the right. So this is basically how you are supposed to solve question 4a. Now let's give a brief description on how we are supposed to handle question 4b. So question 4b, there in your worksheet, there is a graph already sketched for you. So they just want you to write the new graph using that equation. So let's look at it. So I want to comment on question 4b. So question 4b there, it is a graph in a graph paper sketched for you. Then you are being told to say that graph which has been sketched for you is is f. So they just want you to draw another new function, which is h of x, to be equals to f2x plus 3. It means that this graph should be transformed and sketch another one to look like that, to be in that format. So we are undergoing transformation for this. So how do I do that? I have to understand this transformation, the 2 and the 3 applied in f, so that this can be transformed later on. So what do I do? Remember, what does this 2 represent? This represents a what? A horizontal shrink. By what? By factor of 1/2. This indicates that all the x coordinates are being multiplied by 1/2. That's the meaning. All the x coordinates are being multiplied by 1/2. So if they are being multiplied by 1/2, it means that obtain any coordinates in that graph paper for the original function. Obtain any coordinates. So you can obtain this coordinate, you can obtain this coordinate, you can obtain that coordinate, and obtain that coordinate, and that, and that. So you get as many coordinates as possible. So what are you going to do? Draw these coordinates. Maybe draw a table for those coordinates. So what are you going to draw? F of x. The coordinates of f of x, it is this graph which is already sketched. Collect points on that. Maybe you can collect that, which is -4, negative what? -0.4,1. You can collect another one, -0.8,2. You can collect another one, -1.2,3. You can collect another one, 0.4,1. You can collect another one, 0.8,2. Collect another one, 1.2,0,3. So get the coordinates, the visible coordinates you're able to locate them on that graph. And then you start with this function. What is this function? You're going to collect coordinates for 2x. f of 2x. 2 is a horizontal shrink with a factor of 1 over 2. This is x comma y. So all these x coordinates, multiply them by 1 over 2. So if I multiply this by 1 over 2, what am I going to have? I'm going to have 0.4 multiplied by 1 over 2. I'm going to have negative 0. What? Negative 0.2. The y remains the same. I'm not changing them. I'm just changing the x because this is a horizontal shrink. Horizontal means x-axis. Divided by 2, this is negative 0.4, 2. Divided by 2, this is what? Is it negative what? 1.2 divided by 2. Is it negative 0.6? I think so. Negative 0.6. Comma 3. This one this is positive 0.2, 1. This one positive 0.4, 1, and positive 0.6, 3. So this is 2. So these are the coordinates for the first transformation, 2x. In the last column, make coordinates for f2x plus 3. So what is the plus 3 meaning representing here? The plus 3 represents that you are transforming these coordinates here in the second column. Transform them by simply adding 3 to the y coordinate. Remember, this is a vertical translation. So all the y coordinates are going to move plus 3. So 1 plus 3 means that I'm going to have the coordinate negative 0.2, 4. 2 plus 3, it is a 5. It means negative 0.4, 5. Here it will be negative 0.6. 3 plus 3, 6. This is positive 0.2, 3 plus 1 plus that is 4. This is 0.4, 3, that is 5. This is 0.6, 6. So for you to plot this one, what coordinates are you going to use? It is the final column coordinates you are going to use. So 0.2 is here, 1. We are plotting the final one, negative 0.2, 4. So negative 0.2, 4 will be this point. Another point is 0, which we could have gotten the first point, 0, 0, if x of x was 0, means 0, even if you multiply 2 by 0, it will still be 0, but 0 plus 3, it will be 0, 3. So it means that the turning point of your 0, 3, 0, 3. 0.2, 4. 0.4, 5. 0.8, 0.6, 6. So this function is going to move something like that. So the final function will be h of x will be equals to f of 2x plus 3. So you get the coordinates on that graph, the first one which was sketched. Locate whatever points you can locate. You locate uku, you locate uku. Wherever you are standing, put your coordinates for f of x. Next, put the coordinates for 2x. 2x, this 2 means it's a horizontal shrink. All the x values should be multiplied by 1 over 2, but the y value should maintain, starting at 0, 0. And then this f of 2 plus 3. Plus 3 means that all the y values add to the 3. So these are the final coordinates you're going to use to plot this final graph. That will be how you handle question 4b. So this is a revision on transformation rules. on how we have transformed some various functions, describe their transformations, and be able to look at questions. Also worksheet 3, question 8, and question 4. Be able to revise through and understand. Go through, pause, and the like so that you go to understand. Thank you very much.